So let's look at one of those other kinds of integrals. What if I had the integral of x divided by the square root of x squared plus 1 dx? I still am having trouble with this square root. So what could I do here? I can't use x equals the sign again. That trick was saying that 1 minus sine squared of theta equals cosine of theta. So I need a formula where the square of a trig function plus 1 gives me a different trig function. So let's look at my formula here and go back to the version cosine squared of theta plus sine squared of theta equals 1. And I'm going to divide everything in this formula by cosine squared. Why do I do that? I'm guaranteed to have a positive 1 on the left side plus a trig function, and that will be equal to a different trig function. So this is telling me 1 plus the tangent of theta tangent squared of theta equals the secant squared of theta. So if I want to use this formula to clean up my integral, that tells me that x is going to be equal to the tangent of theta, and that dx is going to be equal to secant squared of theta d theta. Let's see what that does for the integral. So I'm taking the integral of this function. The x on the numerator is going to become tangent of theta. On the denominator, I have the square root of tangent squared plus 1. So that's looking pretty good. My dx becomes a secant squared of theta d theta. Okay. So I can use this formula to say that the denominator of this function is going to reduce. So really this is the square root of secant squared of theta, like so, d theta. So I've got a single secant on the denominator. I have secant squared on the numerator. So this is all going to be integral of tangent of theta, secant of theta, d theta. And I recognize since this is the derivative of the secant function, my antiderivative is just going to be secant of theta plus a constant. I don't even need to do a u sub or anything. Now, the last part of this is going to be returning to my x variable. I said that x equals the tangent of theta. I need to figure out what the secant of theta is in terms of x. So for this kind of problem, I like to draw a diagram of a right triangle. I'll say that x is one of these side lengths, and theta is the angle that I'm considering. So, how do I proceed? I know that tangent of theta, this is the opposite edge divided by the adjacent, and this is supposed to be equal to x. So I'll say that my opposite edge is a length of x, my adjacent edge is a length of 1, and I need to solve for this last leg of the triangle. This is, actually, excuse me, this is the hypotenuse. So good old Pythagoras tells me that this is going to be the square root of x squared plus 1. Hey, cool. Secant, I know, is 1 divided by cosine. So if cosine of theta is the adjacent edge divided by the hypotenuse, then the secant of theta must be hypotenuse divided by adjacent. So I have hypotenuse, which is square root of x squared plus 1, divided by adjacent. Secant of theta for this triangle is going to be the square root of x squared plus 1. Okay. So that tells me my antiderivative here is the secant of theta. My answer to this problem is the square root of x squared plus 1 plus a constant of integration.